In this video, we're going to talk about exponent rules. It's a general overview of all the rules of exponents, so take notes as you need to, and make sure you practice so that you know how to use each of the exponent rules. The first thing we have to do is figure out what exponents mean. So what do exponents mean? There are two parts to an exponent. There's the base, so the 4 is the base. That tells you what you multiply. So remember, exponents are like power multiplication. Okay, so the base, the big number, tells you what you're going to multiply, and then the power, or the small number, is how many times you're going to multiply. So how many times you multiply. So 4 to the third power tells us that we're going to take 4, and we're going to multiply it by itself 3 times. So 4 times 4 times 4. When you multiply that out, 4 times 4 is 16, times 4 more gives you 64. And that's how you do exponents. That's how you simplify them. The next example, we've got 2. So 2 is your base, 2 to the 5th power. And then the 5 tells you how many times. So 2 is what you multiply. So we're going to do 2 times itself 5 times. 2 times 2, that's 3. Times 2, that's 4. Times 2, that's 5. When we simplify it, 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 more gives us 32. And that's how we simplify it. Pretty easy, but I just wanted to remind you what exponents were before we got into the actual properties and the rules. So the first one is the 0 power. So what does the 0 power mean? So the 0 power is when you have this 0 right here in the power part of it. So the rule is anything raised to the 0 power equals 1. So anytime you have something raised to the 0 power, it equals 1. Therefore, 5 raised to the 0 power is 1. Easy as that. See how the 4x is inside parentheses? We raised that whole thing to the 0 power, so guess what it is? You guessed it, 1. In the third example, we have 6x squared y to the third inside the parentheses, and that's raised to the 0 power, so guess what? That whole thing equals 1. Be careful when you have something raised to the 0 power and something not. For example, if I have 6x to the 0 power, whoops, sorry about that, 6x to the 0 power, only the x is raised to the 0 power. So this is really 6 times 1, because x to the 0 power is 1, and 6 times 1 is 6. So pay attention to what's being raised to the 0 power. Easy, easy, easy rule. Okay, how about the next one? So we're going to do a negative exponent. I like to think of the negative exponents rule as the exponent is unhappy where it is. Okay, so I call this kind of my unhappy rule. So unhappy rule. All right, remember every number has both a numerator and a denominator. Okay, so in our first example, we have x to the 2nd power in the numerator, and we have x to the -3rd power in the denominator. In the numerator, the 2 is positive, so we're going to leave our x to the second power in the top because it's happy in the top. Okay? Positive power means it's happy, so leave it where it is. In the denominator, we have a negative third power. That tells me that particular number is unhappy in the denominator. So we're going to move it to the numerator and change our power to be positive. So x to the positive third power. Nothing is left in the denominator. So that means that we're going to replace it with a 1. So anytime you remove everything, make sure you have a placeholder of 1 there. We're going to talk more about multiplying with the same bases in the next set, but x squared times x to the third is x to the 5th power. And that's the answer. And when you divide anything by 1, it's that thing anyway. Okay? Our next example, we have x's and y's. So x to the negative 2, y to the third, over x to the 4th, y to the negative 1. So we're going to take this one piece at a time. Our x to the negative 2, not happy where it is because it's a negative power. So we're going to put it in the bottom. So x to the second power. Then we're going to look at our y to the third. Y to the third has a positive power, means it's happy where it is, so we're going to leave that in the numerator. Now we're going to look at x to the 4th, positive power, leave it in the denominator, happy where it is. So x to the 4th power in the denominator. Then we have y to the negative 1. So not happy in the denominator, we're going to move it to the numerator and make it a positive power. Okay? So put it where it's not, make it a positive power. And then we're going to simplify this. And again, we're going to talk about simplifying these in the next set. So y to the 4th over x to the 6th. Different bases, so we have x's and y's. So you just leave it like that as a fraction. Okay, so the unhappy rule, you put it where it's not. Okay, makes sense? Do it one piece at a time, and in no time at all, you'll be simplifying these. Okay, rule number 3. Rule number 3 has to do with multiplying exponents with the same bases, and the bases must be the same to do this. Okay, so if I look at the first example, I have x squared times x to the 4th. If I expand this, x squared becomes x times x. If I expand x to the 4th, I have x times x times x times x. So x to the 4th, I've got 4 of them. And when I multiply all those together, I get x to the 6th. How is 6 related to 2 and 4? Well, 2 plus 4 equals 6. So x to the second power times x to the 4th power, and you can use parentheses or not, same thing, is the same as x to the 2 plus 4, which is x to the 6th. So if you remember this rule, you don't have to expand it, but you certainly can expand it if that'll help. So the next one, a little bit longer, and I've got a couple different variables in it. What I do is I rearrange everything so that I have the same bases together. All right, so I have, and remember, I'm just multiplying everything. There's no pluses and minuses in here, so I'm just multiplying each piece. So I'm going to put x to the 3rd and x to the 5th next to each other. I have y to the 4th and y to the 4th. And then I've got a z to the 3rd, so I can't forget anything. I have to remember everything. Then I have x to the 3rd times x to the 5th, so 3 plus 5 is 8, so that makes x to the 8th. I have y to the 4th, y to the 4th, again 4 plus 4 is 8, so y to the 8th. And I just bring down my z to the third, and that's my final answer. Okay? So when you're multiplying exponents with the same bases, you're going to add the powers. Okay? So just add the powers. And that's it. That's all you have to do for that. Okay, next rule. We're not quite done yet. We've got 2 more rules. So our next one is dividing. And let's see, let's do gold for this one. So this one is rule 4. Dividing exponents with the same bases. Okay. So remember, with multiplying exponents with the same bases, we added the powers. So when we divide, it's an inverse operation. So we're just going to subtract. So subtract the powers. And I'm going to show you a couple of different ways to do this. All right. So for the first one, it's pretty easy. X squared is x and x. X to the third is x, 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 like that. Well, these x's, if I have one in the top and one in the bottom, they cancel each other out. So I'm left with just an x in the denominator. Since there's nothing left in the top, I need a placeholder, and that's 1. And that's as easy as that. I could also do x to the 2 minus 3, which is x to the negative 1. But remember our negative rule? Put it where it's not. It's in the numerator, so we're going to put it in the denominator. Put our placeholder 1. And remember, x to the first power is the same as x. So you get the same thing if you do the canceling or if you subtract. Okay. The next example, x to the 9th over x to the 6th. I'm not going to write this out, but I am going to say x to the 9 minus 6, which is x to the 3rd power. Because it's a positive power, I can just leave it in the numerator. I'll leave you to expand it and make sure that I'm right. For the third one, I've done a little bit of a mixing in here, so it's a little bit more complicated. Just like the last piece, we're going to take it one number at a time, one expression at a time. So we're going to look at the 2. Okay. 2 is raised to no power, or the first power, so it's happy where it is, so we're going to leave 2 in the numerator. Okay. We have 3 in the denominator. Again, it's to the first power, so I'm going to leave that in the denominator. 2 divided by 3 gives me a repeating decimal, so I'm just going to leave it the way it is. Okay, so I've taken care of my numbers, my coefficients. Now I'm going to look at the x to the 3rd and the x to the 7th. X to the 3rd in the numerator, x to the 7th in the denominator. Where are there more? There's more x's in the denominator. How many more? 4 of them. So the difference between 3 and 7 is 4. So I'm going to put them in the denominator. So x to the 4th. The next ones I'm going to take care of are the y's. So y to the 5th over y to the 3rd. Where are there more y's? In the numerator. How many more y's? Well, 5 minus 3 is 2. So I'm just going to leave that there. Y's are taken care of. Then I have to look at the z's. There's only one place the z's are. It's a positive power, so I'm going to leave it where it is. Z to the 2nd power. And it's as easy as that. So when you get a bigger expression, just make sure you chunk it. Take your time and do one piece at a time. And before you know it, you'll have it all right. Okay, so the next one is taking a power to a power. In other words, the power rule. And this is our last rule here. Okay, So when I look at x to the third power and then take that to the second power, what that really means is x to the third times x to the third, right? So x to the third power is kind of like a base. It is a base. The 2 tells me how many times, so I have x to the third there 2 times. So x to the third, x to the third, that gives me x to the sixth, because I can do now x to the 3 plus 3, which is x to the 6. So that's my multiplication rule. The other thing to remember is that how else do we get 6? We can take 3 times 2. So x to the 3 times 2 gives us x to the 6th. So whichever way you prefer doing it, you get the same answer. So x to the 6th is our answer to that one. Okay, so for the next one, we have x to the 5th, y to the 6th, raised to the third power. Now I could write it out 3 times and then use my multiplication rule, but I'm going to use the power rule this time. In order to get the correct answer, we're going to actually distribute our power to the other 2 powers. So we get x to the 5 times 3, which is 15, and y to the 6 times 3, which is 18. Easy as that. So remember, the power rule is when you multiply the powers. Okay? Make sure, though, there's only one base. Okay? So see, in our first example, there's only one x. And then there's 2 powers. There's the 3 and the 2. So that's the difference between that one and the others. We have one last challenging one for you. So let's see if we can do this one. Again, if we chunk it, we'll be okay. So we have 2 and 4. What is 2 divided by 4? Well, 2 divided by 4 is 1/2. Let's just simplify that, get it out of the way. Then we have, in the numerator, we have x squared to the third. Well, we just learned about the power rule. So x squared to the third is the same as x to the 6th. We have y to the 5th. Well, y to the 5th is a positive power. It's happy where it is, so we're just going to leave it where it is. Then we have z to the negative 2. Negative power, unhappy where it is, so we're going to put that in the denominator and change the power to a positive. Whew. Now we have our denominator to deal with. So we have stuff that's raised to the second power. So x to the third power raised to the second power. So that's x to the third power raised to the second power. So that's x to the 6th. And it's happy where it is, so we're going to leave it there. Then we have y to the second power raised to the second power. Positive power, happy where it is, that's y to the 4th. And then we have z raised to the second power. Well, that's really z to the first power. Again, it's positive, so we're going to leave it where it is. Not quite done yet. There's one more step. Okay, and I want you to see this. Okay, so I'm switching colors. So in this one, I've got an x and an x. So x to the 6th and x to the 6th, same power, 6 minus 6 is 0. Those guys cancel out, so I don't need to have an x anywhere. We have y to the 5th in the numerator and y to the 4th in the denominator. There's one more y in the top, so make sure you got that y in the top. There you go. We're done with that. Then we have z to the 2nd, and we have z to the 2nd. And they're both in the denominator, so that gives us z to the 4th in the denominator. Don't forget your numbers. So 1 times anything is that number. So when we finally simplify, we get y over 2z to the 4th. So see, that mess simplified to something easy. Make sure that you rewatch this video so that you know what you're talking about.